geology of this New Irvington tunnel, we had very many areas to where it changed rapidly. Some days every 4 feet we'd find something different, whether it was hard rock, flowing ground, squeezing ground, fault zones, areas to where we had to probe every foot of this tunnel out in front of us to make sure we didn't hit gassy pockets or high water inflows. During the course of the project, over the 18,000 feet, we injected over 7.8 million pounds of cement grout out in front of us as we prior to excavation in the tunnel face. So this is just a profile of the tunnel. David mentioned the portals and the shaft. The red with the fault zones. In particular is what's called Sheridan Valley, just on the other side of this mountain, about 3,500 feet over. The designers were very seriously concerned about the squeezing grounds in those areas. We were, however, able to dewater that valley because it was only about 250 feet deep down to the tunnel. It was the only area to where we could dewater through a pasture over there. And we pulled out between 600 and 900 gallons a day out of 20 wells, reached over about a 1,000-foot stretch. So as we mined through there with our road headers, it was a dry environment, and we literally were able to mine a lot quicker and safer through that valley. As David said, we've used multiple headings with several different road headers, two of which are right behind us here, the Antraquips. There was one third machine that was more robust. They got through some of the harder rock up to 12,000 to 14,000 psi, but there was areas of the tunnel to where the road headers wouldn't even work, so we had to rely on drill and blast methods with explosives to keep the production up. Challenges during the project. David was paramount on the beginning to where in the specifications, because there was a chance of methane gas and hydrogen sulfide, they put in the design specifications to make sure all the equipment that was used underground, including the lights and the ventilation and the road headers and the locomotives, would all be permissible. So in case there was any types of gases, we wouldn't have to shut down for 3 to 6 months if we did encounter gas. It's all explosion-proof equipment. All your electrical boxes are sealed with NEMA 4X boxes. Squeezing ground. We knew that we were going to be squeezing ground along the tunnel. When we encountered it, the geologist would map it, tell the contractor it had to be in a different ground classification to where they narrowed up the sets to 2.5 feet, the steel ones. We put invert struts in and thicker concrete in the invert to stop the squeezing coming in. Groundwater infiltration was huge on this one. We knew the potential was there because of the way the existing tunnel fault and literally flooded out on several occasions back in the 30s when they built the existing tunnel. This is one photograph of just our tunnel, but the grouting really paid off on this one to keep the infiltration down to about 1,000 to 1,200 gallons a minute through the 18,000 feet of tunnel. We also had a large groundwater management program for all the residents from here all the way over to Fremont, where there was up to 13 or 14 of them that got impacted to where their wells went dry. They're all in a well system over there. We had to truck water in for a little over 2.5 years to these residents. And we also built a irrigation line coming off of that dewatering well field I told you about up Sheridan Road, and we were able to tap into our dewatering water, not just dumping it into the creek, but we brought it up a 4-inch line, and all those customers were able to get irrigation water, which was huge, and that was a huge savings for us trying to truck in all their potable water for them. So we're still have a few issues over there. We have 3 more wells to drill for the residents that their wells have not come back or their springs haven't come back, and it's been a very positive part of the program to keep all those people with water the last couple of years.
We have one source of water over on the peninsula, Harry Tracy. The 2 lakes over there are basically filled with Hetchy water. Over on this side, if we lost the old tunnel, Hetchy would not be available to anybody over the hills, nor could we get the Sunol filter plant water in. So 2/3 of our supply would have been down. So that tunnel never got to come out of service. Now we can take either one of them down. Once we put the new tunnel in, we immediately started running tests on it. We got like 300 million through it, didn't we? Or close enough to it to satisfy us. Everybody here sleeps a little better at night knowing we got that tunnel. Without this tunnel, this is our weak link. And without the with a single tunnel, and we just couldn't take it down. Even if we had a problem, we'd still probably have to put water through until we worked it out. Otherwise, a lot of cities in the Bay Area were going to have to go out of water or go on severe restrictions while we took it down, if we had to do that in the past.